Thanks very much for coming. My name is David Litchfield. I currently work for NGS Software. That's about to end in about an hour's time, though. So this is my last gig as NGS Software. Today, we're clearly going to be speaking about hacking Oracle 11G. We're going to be looking at a couple of new attacks that unfortunately haven't been patched yet, but Oracle have been informed. I was hoping they were going to be patched in the July CPU, but we'll talk about that more in a minute. So the fundamental point behind this presentation is to ask the question, has Oracle's security posture changed over the past few years? And where does it stand today? So how easy is it to hack Oracle 11G? Well, we'll see in a minute. It's quite easy, but it's harder, as we'll see in conclusion, than hacking, say, Oracle 10G Release 2. So we'll look at some comparisons. We'll also look at Oracle versus SQL Server 2005 and 2008 and see if there's any conclusions that can be drawn as to security posture from there. And we'll talk about the flaws, do a couple of demos exploiting these flaws, showing what can happen in terms of ramifications, as stated there, complete ownage. And discuss risk mitigation, because obviously giving you the problem without the solution is not ideal, so we'll talk about that at the end. And then finally answer the question, has Oracle's security posture actually changed? I take it, well, just a quick show of hands. Does anybody not know about my sort of fight with Oracle over the past few years? Any show of hands? Okay, that's quite, right. So Oracle and I have been bashing heads against each other for crumbs since Larry Ellison said his product was unbreakable. And I took a bit of umbrage with that and decided to take a look at Oracle. Previous to that, my work had been more in SQL Server. And so, yeah, it's like waving a red flag to a bull, I guess, saying your product's unbreakable. So, yeah, my relationship with Oracle publicly has not been the best, let's say. At one point, I actually called for the CSO's resignation on BugTrack because I think at the time there were massive failures within Oracle. Their patching was atrocious. They would patch one thing and miss a bug 2 lines under the patch, in the code. Or alternatively, their patch would prevent the exploit but not actually address the problem. So, for example, one of the proof of concepts I sent them had a space in it. The SQL had a space in it. And so they checked the input to see if there was a space in the input and denied the request if there was a space. But if there wasn't a space, it went through. Well, we don't need a space. We just go angle bracket, star, star, angle bracket, not angle bracket, slash rather, and make a comment. So we don't actually need a space in the exploit. So with a simple modification of the exploit, the patch is broken. Sometimes Oracle would take 5 years and 15 patches to attempt to fix one single issue. Well, that's a small exaggeration, not 15 patches, it was actually 5 patches. But still, it's a significant number. To fix one small thing, it took 5 patches in 5 years, and I think that was atrocious, so I'm going to reserve my judgment on whether Oracle has actually made any improvements, obviously because that's the basis of this talk. So, since Oracle 11G has been released. Release 2 has since come out, and there are no security flaws in 11G Release 2 which have been patched yet. There are flaws, obviously, because I'm waiting on some being fixed, and the flaws we'll be speaking about today affect Oracle 11G Release 2. But the only stats we have available, and stats are everything in this business, are for 11G Release 1. So it was released basically at the beginning of 2008, end of 2007, I can't remember which. But the first set of patches came out in January 2008, and it patched one flaw. The next CPU came out in April, and you can see 5 flaws were patched in 11G Release 1, and then so on, and up and down and up and down. So since then, 48 have been acknowledged in Oracle's critical patch updates. Some of these are critical, like the last one, January 2010, on a CVSS score, that scored a whopping 10. In other words, complete compromise of the server. That's on a Windows system. On a Linux system, obviously, because Oracle does not run as the super user root, it runs as the Oracle user. It's not a complete compromise, but as far as the database and the data is concerned, it's definitely an epic fail. Some of these are for minor trivial issues, barely warranting a score in CVSS. So, for example, one of them was because with 11G, basically, you can change the old traditional password mechanism to a new super-duper one using SHA-1 hashes. But if you do that, it's impossible to track password history. So for things like PCI compliance, when one of the points is to track password history, because they're using new SHA hashes, you can't track password history. So they've had to modify the code to fix that. So that barely warrants one of these squares, but the point is it's in the CPU, so it has to go in the square. There are a couple of missing boxes because it affected Oracle Enterprise Manager. So whilst Enterprise Manager is installed with the Oracle Database Server, I didn't include them there because I just wanted to actually look at the RDBMS itself. So how does that compare? Oh, sorry, yeah, before we go on, there's a big question as to whether Oracle silently fix flaws or not. And they do, okay? Bottom line is they do because I found them. They say they don't. I've found them. Other people have found them. So let's get over this whole argument. Yes, Oracle silently fix flaws. And big deal, so what? If they didn't silently fix flaws, these graphs would be through the roof, and my slides aren't big enough to hold that. It'd be like Al Gore when he gets on his wee crane and goes up and shows the temperature differences with carbon dioxide in the air and everything, It literally would be through the roof. So I don't care if Oracle silently fix flaws. I can't say that. Fix flaws. So, for example, there is a buffer overflow in DBMS Java test, which affected 10G Release 2 and Release 1, and that was fixed in July 2007, but it also affected, God knows how it got into the code, but it also affected 11G Release 1. But their first patch basically fixed it, but they didn't announce that, this was being patched. But it's not a big deal as far as I'm concerned. So if we look at Oracle 10G Release 2, this is how many bugs have been fixed in their CPUs, publicly acknowledged bugs. If we look at the first 2 years, 2006, 2007, for a comparison, we can see there's a vast improvement in 11G Release 1 over there. So in the first 9 quarters, since 10G Release 2 was released, 73 flaws were fixed and acknowledged. With 11G, 48 have been fixed in the first 9 quarters. That represents a drop of 35%, which is actually really, well done. When Microsoft turned around and compared bugs found in the first quarter or first year of XP versus Vista, I think the drop was about 35% as well. So that's within, industry norm when we look at the world and ask the question, is software getting more secure? Is its robustness, improving? A drop of 35% between major revisions, I think, is a good hit, basically. So they've done really well on that. I also spoke about some of those flaws in that graph for Oracle 11G, some of them being for such pants issues as like password history tracking. It's not going to allow someone to own your system, but it's still on there. So the severity are also down for these things. There are far fewer SQL injection flaws in 11G Release 1. They've done superbly well. Their tool, their flow analysis tool, has done a great job of finding probably 99% of all SQL injection flaws in 11G Release 1, and I think that's really great. Buffer overflows, not so great. There's still a couple kicking around, but I tell you what, it's a damn sight better than previous versions of Oracle, especially like back in the Oracle 9 days and so on. You just had to look at Oracle to exploit a buffer overflow in those days. The fact that there are fewer high-risk critical flaws begs the question, is their toolkit, is their tool chest actually doing what's expected of it? There are still some areas where they need to improve, and we'll obviously talk about that and why these flaws are actually in there. This graph is for SQL Server 2005. That's been around for as long as 10G Release 2, and that's how many flaws have been fixed and found in Microsoft SQL Server 2005. Just want to compare that with a product that's been around for a shorter amount of time. So we can see SQL Server has done really, really well. The SQL team have done really, really well there. Now, people will say, but, no one's obviously looking. It's Microsoft we're talking about. You know, we had an argument about this at the beers last night. You know, one of the chaps was like, yeah, but it just shows that people aren't actually looking for bugs. Well, it's nonsense. This is Microsoft. Find an O-Day in SQL Server 2005, and you'll be able to sell it to iDefense for £100,000 probably, you know. So people are looking for flaws in Microsoft SQL Server. It's just that they are so few and far between. And SQL Server 2008, been around for as long as Oracle 11g Release 1, 0 security flaws. So again, I think Microsoft have to be applauded on that score. Not so great on IE, I guess, at the moment, but definitely brilliant work done with the SQL team. So context established, you know, giving Oracle their pat on the back and saying, well done, Oracle, you have made vast improvements. There is still obviously a bit of a way to go. So let's look at some of these new flaws and ask the question, why are these flaws in the code, and what can be done to improve their processes to make sure Oracle 11H or whatever it happens to be, when that comes out, has, again, 35% fewer than 11g Release 1. So within Oracle, there is a virtual machine, a Java virtual machine, and Oracle term it Aurora. And the surrounding infrastructure behind the way they implement that virtual machine, I've spent the past few months looking at basically to find holes in there and have a good poke around in there. Now, as part of an upgrade, if you're upgrading, you know, one database server to another version, there are some tools available to allow you to do that, part of the data pump suite of tools. And it's installed by default, and one of these packages is known as DBMS JVM XPerms, export permissions. And that has a procedure called import JVM perms. Now what that does basically is we provide it a list of permissions, and it basically updates the Java policy table, i.e. the policy table is where, you know, the security permissions for certain Java actions are stored basically. So if we want to read and write to the OS, you know, files and so on, we need an entry in this policy table to allow us to do that. Or if we want to execute arbitrary OS commands, we, you know, have to have an entry in this policy table. Now, the thing is, obviously being able to execute arbitrary OS commands or read and write to files, that's a bad thing. So by default, Oracle doesn't allow users, low privilege users, to do that kind of stuff, as they should. That's expected. But there's a flaw there. When they ship this package, basically, they've given public the execute permissions on it, execute permission on it. So that means public can execute this package, provide their own, you know, permissions, and have the Java policy table updated. And yeah, I'll show you this rather than whittle on about it. I'll do the demo. So the user we're going to be attacking from is called Gremlin, and help if I could spell. And if I show you what they've got, can people see what I'm typing on this screen back here? Is the font big enough, yeah? Select star from session privs. As you can see, I've only got create session privileges. I can't create procedures, can't create tables, can't do anything other than simply connect to the database server. Session roles. No rows selected. Gremlin has not been assigned membership of any roles. So they're as lowly as they can possibly get, basically. This is a user with pretty much zip permissions. So I'm now going to log in as sys and show you that Gremlin has no Java permissions specifically for him on the DBA Java policy view. That view basically just points to a table called Java $policy $. If you're, you know, interested, here we go. Java $policy $. So this here is this is the table where the actual information is stored, and the view that accesses that is DBA Java policy. Now, I'm going to log in as Gremlin and grant myself these permissions the permissions to execute an arbitrary OS command using this dbms Java perms, export perms package. So I'll quickly cut and paste it and describe what I'm doing. Is there a laser pointer? Let me see. Right, excellent. So here, we're basically creating a cursor for ourselves and selecting the entries that we need, basically, to go into the policy table. So we want the IO file permission on all files, and we want the execute, okay? Because we're basically setting it up so that we can execute at some point an arbitrary OS command. And once we've done that, we execute the query, fetch it into this policy here, and import the policy executing here, dbms Java export perms, import the Java permissions that we've just set up here. And once that's done, obviously it says PL SQL procedure successfully completed. So now let's log back in as sys and actually see if we've got those Java permissions. Okay, so you can see now that previously we didn't have the, Gremlin didn't have the permission, but now he does. He can execute any file he wants on the file system. That is if he can find a way, of course, to break out of the database server and execute commands, because remember, he's only got the create session privilege. Well, is there a way? Rhetorical question. Of course there's a way, because it's Oracle. They always provide us the way. Running arbitrary OS commands. So he has the relevant permissions now, but he doesn't have the create procedure privilege. So if he did, they could just simply, do a create Java source named whatever and write Java directly into, into the database, wrap it around a PL SQL procedure and execute the OS command that way. But he doesn't have create procedure privileges, so he's stuck. But is there an extant Java class that will allow a given user to execute arbitrary commands? So the Aurora basically is one big zip file, and it all gets unzipped, and there's a whole load of jar classes. Who's heard of JAD at all? It's like a Java. Okay, so using JAD, basically, you can get the clear source code back out from that. And there's a class called wrapper, where if we look through it here, there's a method main that takes string arguments and passes the arguments to this parseargs launcher, and down here we get this runtime.getTime.exec.cmd. So this basically, when we execute the main method, will take the user's argument, pass it to this launcher, and execute this OS command basically. So let's reconnect as Gremlin. And execute a command. Before I execute it, let's show there's dir out.lst. There's no file called out.lst. What I'm going to do here is this package, this package here, dbms Java, has a function called runJava, and what runJava does basically, it takes the name of a Java class and executes its main function and passes it whatever input you pass it. And the specifics are, it has to be the main function. In other words, if the Java class doesn't have a main method, then this runJava would fail. And it also has to have a specific method prototype and so on. But luckily enough, well, unlucky enough for Oracle, this wrapper class has exactly the what we need to actually pass it to this runJava. So this basically is our attacker using this dbms Java package as a harness to get through to run an OS command. So hit enter. Looks like nothing has happened, but the file has now been created. What we've done there is basically launched the command interpreter cmd.exe, pass it the /c argument. That means basically run a single command, dir, redirect the output to this file out.lst. We could do whatever we want. So if I go net user gremlin, we can see there's no user called gremlin. So let's go and create ourselves. Obviously, this is all going local on my machine and everything, but this is actually a remote attack. This is as if I was connected, remotely to an Oracle server. So I'm going to go back down here. Net user gremlin password /add. See if this works. So we've now created an operating system user by exploiting this flaw. So coming from 0 privileges other than create session, we now can obviously add this to the local administrators group. Net local group administrators gremlin /add. And we can see now he's an administrator, gremlin's an administrator. So we've just created an operating system account and made him a local administrator. So you can see it's not very good. Right, what I'm looking for. There we go. So suffice it to say that I can run arbitrary else commands using this. I can obviously do exactly the same thing to create files, delete files, and so on. But I'm not going to waste time doing that because there's much more exciting things to do. Okay. Again, hacking around the whole Aurora place. Great, we own the operating system and everything like that, but as far as the database server is concerned, we still only have create session privileges. Yeah, we're still that lowly little user. What we want is to gain sys privileges or DBA privileges. So here's how you do that. This dbmesh Java package, the one that had the run Java function on it, has a procedure called set output to Java. Now, what this does basically is any output from to system.error and so on, we can redirect that output to either another Java session, to SQL or whatever. Now, if we set the output to another Java session, what happens is the Oracle database server kicks off another Java session with a new session state and so on, but it does so with the privileges of the sys user, and because sys owns this dbmesh Java package. So when this VM executes, it's owned by sys. So anything that happens in that new VM session basically executes with sys privileges. And as part of the specification for set output to Java, it can take arbitrary SQL to execute either before or after the new VM receives the output. So what we can do basically is inject well, it's not really inject because we're not inserting anything into extant code. What we're doing is just supplying lock, stock, and barrel full SQL to execute. So let's do this. Oh, and that SQL will, of course, execute with sys privileges. So just connect as gremlin. What I'm doing there basically is, because we want to see output and stuff like that, it's part of the hack, we need to set the output. So we then, again, no roles awarded to us, and there are no privileges other than the create session. That's all about to change. So what I'm about to do here is this is the set output to Java function we're about to execute. This is irrelevant, really. We just need some class to execute. And here is the arbitrary SQL we're executing. Declare pragma autonomous transaction. That's a way of tricking the PL SQL compiler into doing stuff it shouldn't be doing because it's transaction-based. What we're saying is, it's okay to do this stuff because there aren't any transactions, but wink, wink, nudge, nudge, there actually are, but don't worry about it. It's all safe and everything like that. And what we're actually going to do is grant DBA privileges to Gremlin. So hit enter. So that's us primed now. This is all ready and waiting. As soon as the new Java session gets some output, it will execute that SQL. So what we need to do now is cause some output from Java to be written. We do that using any number of methods. The one I'm using here is executing dbms cdc isubscribe, executing the internal purge window procedure. As I said, it can be anything, but by doing this, an error is going to be kicked off, and that error will write Java output, and that output will kick off the SQL in our other Java virtual session that's sat waiting, basically. So hitting that, there's our error, as expected. And now, if we go set role, DBA, we're now DBA. And if we do select star from session privileges, privileges, select star from session priv. What am I doing wrong? Oh, session privs, sorry, that's why. So you can see now we've got all the privileges under the sun, basically. So from lowly Gremlin user who only had create session, they now have complete control over the S, they now have complete control over the database server as well, because they can do anything they want. What does that practically mean to government guys? I'm sure a lot of you are probably using things like Oracle label security. So I'll show you how we can do some neat hacks to defeat Oracle label security. So what we could do is use that SQL injection flaw. Well, technically it's not really a SQL injection flaw. It's just dumb. That's what it is. It's a dumb flaw. Really, you'll see in the slides later, it's like when people sat down and were thinking about programming this, which idiot thought of it? Which plonker actually turned around and said, hey, this is a good idea, let's do this, execute this as sys. You know, it's crazy. But we'll get back to that. So yeah, bypassing Oracle label security. Oracle label security basically is Oracle's super way of basically managing information at different levels of security. So for example, confidential, secret, top secret, and so on. Mandatory access control, basically. This has been evaluated to EAL4 under the common criteria. And there are, amongst other ways of bypassing it that I'm showing you here, there are other interesting things. Actually, let's talk about that. It's not actually my slides, but this is from CD OLS DIR. And this is the security target, I think. Yep. Tow summary, protection profile claims. Actually, here's it in that one. dr_star.pdf. This is the evaluated configuration, that's right. Oh! Display drivers stopped responding, but we're still good. Right, excellent. Profile A, script listing. There's a couple, for a product which has been evaluated to EAL4, there's some worrying things in here, like the security functions that enable, assist as part of the, the target of evaluation have flaws in it. It's like there's a second order SQL injection flaw. They create a user with a default password and don't do anything about it later on. And so people who have actually followed the evaluated configuration are at risk because of the configuration, Sorry, give us 2 secs. Actually, I'll find that at the end because we're interrupting the flow of the actual presentation itself. So one of the ways in which Oracle themselves acknowledge that Oracle label security could be bypassed would be if a user could arbitrarily load a random, well, not necessarily random, a bad DLL into the address space of the Oracle process. A DLL is a dynamic link library. It's like a shared object on Unix systems and so on. Now, if an attacker can do that and load their own code into the address space of the Oracle process, then they can obviously start doing things like bypassing Oracle label security. And that's specifically mentioned in their OLS documents. Now, because loading a library is so dangerous, not even for Oracle label security, Oracle actually disallow even the sys user from loading a library into the address space of the Oracle process. But by using this Java hack that we already spoke about, this permissions hack, we can actually bypass all that stuff, load a library into the address space. So let's do that. So there's a library here called MyDLL. MyLib it's called, sorry, mylib.dll. So we're going to load this library. The source for it is quite simple. Type mylib.c. So that's the code. All we do is create a file called Oracle OLS libtest. That's probably cd app, cd David, cd-dir/s. Hopefully it doesn't exist. Whilst that's going on, I'm going to load the library. Okay. Now, remember, Gremlin has awarded themselves all the privileges under the sun, so things like create procedure, they now have. So what he's going to do is create some Java source named myLoadLibTest that basically loads a library, takes an arbitrary name and loads a library. It loads that library. So here goes. We go with that. So we've just created that Java. We're now going to pass that to give ourselves, the load library permissions. So again, we've used the dbms JVM export permissions package to import the runtime permission load library on any library we want. See that .star at the end? That basically says we can load any library we want now. And we use our good old friend Java test func all to do that. Now what this does basically is takes the name of a method and takes the name of a class, its method to execute, but again it has to be of a set type, and then passes it any parameter. And the parameter we're passing it here is mylib.dll. But remember, we have to do and // because it will look in the current working directory, which is somewhere in here. CD product CD CD db2. I think this is going to be the somewhere in here is the current working directory. So using the ... basically, that's going to allow us to load the library from a different part of the file system. So if we start capturing this here, this tool here is Process Monitor. It shows what's going on in the background. It's just a DLL I've created. You know, my attack, basically, I would create the DLL and upload that onto the server using this Java hack, basically, to load it into a table, export it load it into a table as a blob, export that to the file system. So I've now got a file called mylib.dll, which contains my Trojan nefarious code, which I'm then going to load into the address space, and that the DLL main function. Where are we? cd \type. mylib.c. All it does basically, this DLL main function here, the code it's going to execute when it loads into Oracle is create a file called Oracle OLS libtest, close it, and then. But if I wanted to do something really nefarious in there, I could, but it's not nefarious. But it's just for demo purposes. So if I was wanting to do bypass OLS with this, I would basically write code to bypass OLS and put it in here, in the DLL main function. So if I hit enter, and we go back here, we can see Oracle has loaded the library into, this is mylib, for those that can't read at the back, that says mylib.dll on the root of the C drive. So it's loaded the library, and when a process loads a new library, it executes the DLL main function, so any code which is in there will execute. So now that file should exist, and there it is. Okay? So we've seen that we've loaded arbitrary code into machine code into the address space. Now we've done that, we not only own all the data, we own everything, we can bypass everything, do anything we want, basically, to the Oracle database server. Back here, how are we doing for time? If you don't want to go to all that trouble, as I said, we could just use the SQL injection flaw to bypass OLS and grant ourselves exempt policy access. So that way when we log on, because we've got this privilege, OLS policies will not apply to us. Same with virtual private databases, VPDs. We can basically get all the data we want. So if we are cleared, say, for access to secret data in an OLS policy table, we can now get access to top secret and everything. All media access, not media access, all mandatory access control is gone. This DBMS Java function is really useful when it comes to auxiliary inject functions. Now, to quickly explain what that is, if you have, say, an arbitrary SQL injection flaw in Oracle, sometimes it's difficult to execute arbitrary code. So what I mean by that is, if we're in the middle of a select statement, let's say there's a SQL injection flaw in a procedure owned by sys that does an arbitrary select on some table, we can't just, like in, say, SQL Server, go semicolon, grant DBA to whoever and do this. You can't batch statements and stuff. So sometimes, if you're limited by the actual flaw itself, you need to inject an auxiliary helper function, essentially, that allows us to do what we want. So in this case, we would say grant DBA to public and so on. But we inject that. See that vuln proc? That's the vulnerable procedure. It's obviously fake. It doesn't exist on the system in the real world, just for demonstration purposes. And that's because SQL injection problems are so few and far between on 11G. I had to make my own one up. It was quicker to do that than find one. 10G release 1 or 2, it would have been quicker finding a new one than writing a vulnerable procedure, funnily enough, which is quite ironic. And so what we can do there is use this set output to SQL, which is a different function. This does not execute as sys, but because we're injecting it into a sys-owned procedure, it will then assume their privileges and execute as sys therefore. So once we've set it up, we then run something like the Oracle Aurora util test class, and the SQL will then execute. If, however, we were injecting this via a web-based attack, we need to concatenate the two and put the attack in one single request, simply because the session may be torn down between two web requests, and our session state and everything will change. So basically all we do is embed our output to SQL statement inside the run Java statement. So this executes first, sets up our attack. Then when this one executes, an output is generated to system.out or system.error. Then the SQL is triggered and so on. So just to show you, this can be used as DBMS Java can be used as a great auxiliary inject function and even used over the web as well. So preventing attacks. Clearly, the easiest method to stop people from exploiting this is revoke public permissions on DBMS Java, Java Test, and DBMS JVM export permissions. When the patch becomes available from Oracle, obviously you should install those as well. Everyone installs patches here, right? Within the first 6 months? Yeah, I reported this back to Oracle last year, and I was hoping that it was going to be patched in the CPU, but since we're a limited audience, I've decided to go ahead with the talk. There is going to be a white paper that will be released to the general public at a much later date when Oracle have actually released fixes for this. But until such time, the actual paper will not be made public. So you're getting a sneak preview, so shh. Okay, so has Oracle security posture improved? Yes, it has. It's improved a great deal. And as much as it pains me to say it, well done, Oracle, you know. I'm not so sure, however, that their SDL processes, SDL is the security development lifecycle that, sort of was, I'm not going to say invented by Microsoft because there were security development life cycles out there before, but certainly made famous by Microsoft. Mike Howard, great guy, did a lot of excellent work there, and Steve Lipner and so on. Now, what SDL does, basically, it goes through every single stage of your development process, right from the drawing board stage all the way through to the very end, and it's a continuing process, so even when the product has been released, you're constantly, trying to improve on that code to ensure that there's nothing wrong. Now, why are these bugs in there? They're not, your typical SQL injection bugs. They're not your typical buffer overflows, but they are still bugs. But they're interesting. It's slipped through the net somehow. Now, as far as I'm concerned, I want to know which plonker thought that was a good idea. At the development stage, prior to the development stage, they actually, someone should have said, that should have been caught there and then and said, actually, this is dangerous. This is not a good idea. So if they'd done that at the requirements or the design phases, it wouldn't have gotten any further. And as you can see, because they're so subtle in the way they work, unless you know what, like the DBMS import Java, export Java permissions does, you're not going to really look at the permissions, see whether the public has execute on it, and so on. So that slipped through the net simply because, actually, reverse that. A later code review or pen test would not have found that as easier as finding it in the design stages, because there's a lot of code to go through and so on. There's the second one, which is the executing arbitrary SQL through the DBMS Java set output to Java function. Unless you actually read the documentation, you don't know that it's actually kicking off a new JVM with a new session state and so on. So these things are very subtle in the way they've slipped through. So Oracle really can't be blamed for these getting in the... Well, they can, sorry, let me rephrase that. They should have been caught at stage one. But once they got past that stage, once they entered the code, it would be really, really difficult to find these flaws as far as I'm concerned. Unless you're a super uber hacker like me, of course. That was me being ironic, by the way, or attempting to be, or making a joke. I'm not that conceited. Well, maybe I am. So the question is, why weren't they caught at the later stages? I think it's really difficult to have had spot these things at the later stage. I think Oracle rely too heavily on their security tools. They're using them as the goalkeeper. Actually, you guys don't watch soccer. In Britain, we play football, which actually we use our feet for. You guys could play football and use your hands, right? It's soccer, what we call football in the UK. We have goalkeepers, to prevent people from scoring goals. A goal is the wee square thing at the end, and people boot into the net and stuff. Okay. They're using their tools too much as goalkeepers, as far as I'm concerned. They're thinking, we can code the way we normally do, we can develop and think of our ideas the way we normally do, because our code will save us, our security tools will save us, and they don't. And whilst they do in a lot of cases, and we've seen that there are very few SQL injection flaws in 11G Release 1 now, and even 10G Release 2 is vastly better than 10G Release 1 because of these tools and everything like that. I think there's still too much reliance on these tools. So in conclusion, they don't have to go all the way back to the drawing board. They just need to tweak it a little. So, if I was a teacher and I was giving Oracle a grade, I'd give them a B+. And yeah, with a wee bit more work, they would definitely get an A-. Still not there, but vastly, vastly, vastly more superior to where they were even 2 years ago. So round of applause, Oracle. And that, ladies and gentlemen, is the end of the talk. So I'll see if there's any questions. Yep, sure, gentlemen at the back.
Actually, two questions. So, your example was you loaded a DLL main. Does it have to be a DLL main, or do you load an arbitrary function?
Well, yeah. The easiest way is doing it in DLL main. If we don't put it in DLL main, what happens is that nothing will ever call the code. So let's say we had a function called foobar. The Oracle process would never call foobar, so it would just remain. The code would remain there and do nothing. So that's why we put it in DLL main. Oh, no, well, no, once from DLL main, we can kick off threads, we can do what we want, and, we can put more functions in there and call them. But I'm just saying, if we have a function called foobar, and, upload that, foobar will never be called. So we need a way of triggering that, and that's through DLL main.
So it has to be DLL main as well?
Correct. Yeah. Any other questions? Is there a question there?
Yeah, the JVM is running inside the Oracle process?
Correct.
That's running on Windows as some sort of server service?
Yeah. The Oracle process is running as a system service, and the JVM is inside that Oracle process, basically. It's within the address space of the Oracle process. And on Linux as well, the processes are divided amongst, like the shadow process and the database log writer reader and everything like that. They're all in different processes, but it's still within the main Oracle process. It's not like kicking off a Java process. Any other questions? We've got 10 minutes, so you get an extra wee break. I'd like to thank everybody for coming to the talk. I hope it's been useful for you. And yeah, thank you.